All right, so we're still talking about exponential functions. Today we're going to talk specifically about growth and decay. So growth and decay, these are just some fancy words for the graphs that you've already seen before. So growth is something that's going to be getting bigger, right? And it tends to look kind of get steep really, really quickly. So remember, we talked about these get large very quickly and they get small very quickly. So there's my growth. And then decay, very similarly, just gets small very quickly. So the two things that I want us to note here, though, that are new, domain is going to still be all real numbers. Remember, for the most part, our domains are always all real numbers. And that's because these are going to continue in the x or the x direction forever. Think about our table, right? Like we could multiply or divide. We could go either direction. Even though some directions give us difficult numbers to deal with, we can still keep multiplying or dividing. Our range, however, is what's going to change. And our range, notice that, and you'll see this when we really start working these problems, these functions never really dip below that x-axis, which means my y values are always positive. So then my range is y greater than or equal to 0, because this graph is never dipping down here into the negative y values. It's always going to stay positive. All right, the same thing for decay, y going to be greater than or equal to 0. All right, and then a last few things I want you to know about growth versus decay. Growth has these three components. It's going to be getting bigger, which we already talked about that last week. The pattern is going to be greater than 1, which we kind of touched on just a little bit yesterday. And it's going to be in this same format where the first number is still going to be my starting value. And then when we talk about the pattern itself, we are going to do 1 plus the percent that they give us. And remember, the percent that they give us, we want to write the percent as a decimal. In comparison, decay functions are going to get smaller. They have a pattern that is less than 1. And the function is still going to look very similar, where this first value is the start, and the parentheses are the pattern. However, this time we're going to do 1 minus the percentage, just so that we get a number that's less than 1. That's the only way we're going to be getting our function to be smaller in the end. So we're going to do 2 examples today. This is one of them. And the first thing we're going to do is we need to write an equation using the information they give us. So it says a painting is sold for $1,800, and that is going to be my starting value. And then it says the value increases. So that should make a key note to you that this is going to be an example of growth by 11% each year. So using that information, I can go ahead and write my equation, and that's going to be f of x equals my starting value. Because it's growth, we're going to do 1 plus the percentage to the x. Okay, so my starting value is 1,800. 1 plus the percent. Now remember, 11%, we have to change that to a decimal. So the decimal place is at the end. We move it twice, that's going to be 0.11. Now this question is specifically asking us to find the value of the painting in 30 years. So what we're going to do is we're going to use this equation. We're going to use the table function in our calculator to answer that question. So because our calculators are at school, this is one that we'll come back to tomorrow. So in your notes, you just need to leave some space so that we can work this problem and get a final answer tomorrow. Okay, so here's another example. This one tells us that the value of a car is depreciating. Okay, depreciating is another word for decay at a rate of 5% per year. So this is going to be the percentage that I use with my pattern. Remember, 5%, I'm going to need to fix that. So I tend to go ahead and write that as 0.05, move the decimal 2 times. And then they already give me a starting value of 32,000. So when I go to write my equation, I have f of x equals the starting value 32,000. And then because it's decay, I want to do 1 minus this time, 0.05. And then we have to have our variable as our exponent. And just like our last example, we are going to use this function in our graphing calculator to answer the question, what will the value be in 2013? So again, you probably need to go ahead and copy the question down. And tomorrow we'll start with our graphing calculators on how to use the table function to answer this question in the easiest way possible.